Hey guys, welcome to session 18 of Java Full Stack Made Easy. So let's first talk about what we discussed in our previous session. So we were talking about the concept of abstract classes in Java. We have also seen where do we apply abstract classes in real world. So one last example that we have seen with the abstract class was about the bank accounts, where we created a class called as bank account, where this common functionalities were introduced, which is deposit, check and check balance. And there was one functionality, one behavior which we just declared but did not define it clearly. That's because each of the type of bank account will behave differently. So here we created a withdraw method and made it an abstract method because these two type of bank accounts, the savings and the current account, had different set of rules for withdrawal. Savings bank account checks whether the minimum balance is 500 available after deducting the balance or not, and current account does not check that minimum balance rule. Okay, so that was the last example that we have seen, and we have implemented the same in current account, where we are not checking for the minimum balance, and whereas in savings account we were checking for the minimum balance. So hope the concept about this is pretty much clear to you, also the rules of abstract classes and the abstract methods. So let me and also we discussed about the concept of dynamic method dispatching. So hope those concepts are clear to you. Let's go ahead and we will now talk about another very important concept in Java, that is interfaces. And I've already added the assignments for abstract classes, so I encourage you to go through with these assignments and complete these assignments before you start the next session. So let's go and start up with the next topic that we are discussing here, which is gonna be interfaces. Now, whenever we were creating abstract classes, if you remember in the previous session, we created something called as bank account. Okay, and then we created two child classes of this bank account, which was a savings bank account, and then there was a current account, right? Let's saving account, let's see that first, and then we will move to the concept of interfaces, and then current account. So these were the two classes that we derived from the bank account, and here we created functions like check balance, and then we created a function called as deposit, and then lastly we created the concept of withdrawal, the withdrawal function, which was an abstract function, right? Withdraw, this was an abstract function. So what was happening was, since the savings account and the current account both are the child of this bank account, so they were automatically inheriting both of this, and only these two classes were defining the body for the withdraw method. Okay, so here the withdraw method body with minimum balance check is what we implemented, and here withdraw method we created. Here there was no need of what, minimum balance check, no minimum balance check. So this way we implemented our previous example. The problem with the previous example was that these two classes were child itself. That means whenever you are using abstract classes, no doubt they are very much useful in scenarios like this. But what if the classes are not related? What I mean is, every time you want to inherit the behavior of an abstract class, the next class has to be a child of it, right? The child classes only can inherit the behavior of an abstract class. What if there are classes that share common behavior but they are not related to each other? Now, what do I mean by classes sharing the common behavior but not being related to each other? Let us understand that in details with example, and with the example I hope you will be able to understand. Common classes can share the common behavior without being relative. So let's say what I have is, I have three classes created here, 1, 2 and 3 classes. So these three classes, what I will name them as, let's say this is the bird class, then this is an aircraft, and then lastly Superman class. So now if you analyze these three classes in details, all of them can fly, right? So birds can fly, aircraft fly, and then Superman also flies. So all these three classes, they fly, but they are not related to each other. Bird cannot be a parent of aircraft. Superman cannot be a parent or child of an aircraft, right? So Superman can have a parent class as person. Aircraft, maybe some vehicle or something can be a parent of this, and bird in itself is a parent. Child of bird classes can be created, right? So they are not at all related to each other, but they are sharing the common behavior, correct? So this is a situation in previous situation, whenever we were creating abstract classes, at that time common behavior was shared among the child classes, but here they are not child classes. That means in my previous example, if you see the savings account and current account, they are siblings, right? They are siblings. Their parent is bank account. So obviously they share a lot of common behavior. They are related to each other. But if I show you this example, these bird, aircraft, Superman cannot be siblings, right? I cannot create a parent class and call a parent class as person, and from person Superman is inherited, aircraft is inherited, bird is inherited. No, that's illogical. So but now what is happening is there are non-related classes sharing common behavior. So what should we do in these cases? So these are the cases where we bring in the concept of interface. So interfaces can be used here. So difference between an interface and abstract class is that abstract class creates a kind of relationship among the classes. So this two classes will be related to each other when you are using an abstract class. Whereas if you are using an interface, interfaces does not create the kind of relationship among the classes that are inheriting it. Inheriting in the sense that are implementing the interfaces. So here all these three classes, they are just utilizing this functionality. They share the common behavior fly, but they are not related to each other. So wherever you find out that non-related classes are sharing common behavior, ensure that you implement an interface, not an abstract class. So one limitation of an abstract class is that classes can inherit from only one class, right? If a class has a parent, then it cannot have another parent. So two classes cannot be parent of the same class. Multiple inheritance is not allowed in Java, but more than one interface can be implemented with a class. So that is another advantage of making use of an interface. So you might have heard this term called as tight coupling and loose coupling. So abstract classes creates the tight coupling. The objects are coupled tightly here in abstract classes, whereas if you are implementing interfaces, objects are loosely coupled. Now what is tight coupling and what is loose coupling? I'll give you one simple example by which you can understand. Coupling basically means combining the objects. Okay, see here, a savings account and current account and bank account, they are coupled with each other, right? Similarly, bird, aircraft, Superman and flyer, they are also coupled with each other. So this is loosely coupled, whereas this abstract classes creates a tight coupling. So what is tight coupling? See, take an example of a laptop and the touchpad in that laptop. So touchpad in that laptop cannot easily be replaced because it is tightly coupled with the laptop. Now to understand loose coupling, understand the same example. Take the example of a laptop and attach a mouse to it, right? So when you are coupling your mouse with the laptop, you can easily remove it. So that comes under loose coupling. So I hope with this example you have easily understood the concept of tight coupling and loose coupling. So whenever you are creating abstract classes, child classes will be tightly coupled with the abstract class, whereas if you are creating interfaces, it will be loosely coupled. And as a programmer, we have to ensure wherever we can loosely couple the object, we have to implement that strategy of loose coupling, because end of the day it should be easy for us to replace things. Like if there is some problem in my mouse, I can easily replace it. But if there is some problem in my touchpad, it is hard for me to replace it. So whenever you are designing an application, ensure that you try to bring in loose coupling as much as possible. Okay, so interfaces first brings in loose coupling. Also, interfaces, they, if classes share common behavior and they are not related, then in that case interfaces will come into picture. So interfaces are of interfaces were enhanced in Java 8. So we will first learn interfaces, how they were introduced. Later we will see what changes were made into Java 8 when it comes to interfaces. Okay, so as for now, we will not talk about the new things that were introduced into the interfaces from Java 8. We will first talk about the interfaces, how they were created, what was the use of interfaces. After that, we will see what exactly is added into interfaces. Okay, so let us now create the example which looks like this, and we will understand how things work and also the set of rules that are associated with the interfaces. So I'll first create an interface and call it as a flyer. So class and interface flyer. So I could have chosen an interface while creating it, so I will change it here. So public interface flyer, and this flyer will have a method called as fly here, and the return type of the method will be void. Now you notice that I am not giving any body to this particular method, and if I say void abc and try to give the body to the interface methods, it is not possible. Interface methods cannot have body. Abstract method do not specify a body. So the rules for interfaces are as follows. Interface is set of abstract method. That's point number one. Point number two is that, so since it is a set of abstract method, that means all the methods return into an interface are abstract by default. That means they don't have the body. So interface methods don't have body. Then interface methods don't have body. Then all interface methods are public by default. So we will see this first. So all three rules. See, we have seen that interface methods cannot have body, and interface is a set of abstract methods. So because it is a set of abstract method, we don't need to specify abstract here. See, if I do the same thing in a class, it gives me an error saying that you have to add an abstract keyword to this, right? Because a class can contain an abstract method or a non-abstract method as well, whereas interface is set of abstract methods. So all methods written into an interface are by default abstract only. So we don't need to write it as an abstract method. So let's create the classes that are going to implement this interface. So as taken in the example, I'll take a bird class. Similarly, I'll take the aircraft, and lastly I'll take a Superman. Okay, so three classes which are not at all related to each other. Will be sharing the common behavior fly. So here is the design of my application. So bird, aircraft and Superman, all of them flies. So that's why I'm just doing an implements flyer. Okay, the moment I implement flyer, you will notice that it started giving me an error because this flyer interface contains a method called as fly. So I have to override that method. So add unimplemented method fly. So we'll just say system.out.println bird flies. Similarly, whichever class is implementing this flyer, I have to have that fly method implements flyer. So I have to add this method, and then aircraft flies, and the same thing I'll try to implement with the Superman as well. So all these three classes, they share the common behavior fly, but they are not at all related with each other. They are not the parent and child. Now you might say that here an abstract is not written, right? Still the method is abstract. If I don't override it, it was showing me an error. Now the next point is public is written here. How do I prove you that it is public? If suppose I make interface method as protected. So if it is protected, this has to be what? Either it can be protected or public, right? It can be protected or public. So the moment I make it protected, it says what? Illegal modifier for the interface method fly. Only public, private, abstract, default, static and strict FP are permitted. That means you cannot make an interface method as protected. What is the reason for that? Reason is clear cut. A class is not a child of an interface. That is why protected access specifier cannot be used. Where do this protected access specifier gives the access? Where is it visible? It is visible to the child class and the package members. And what is the purpose of using interfaces? Non-related classes can share common behavior. So if you write it as protected, first of all, there cannot be child classes of an interface. Second point is that classes belonging to the same package cannot use interface. Why is that? That's because interfaces are meant to be utilized by classes belonging to any interface, not just the same interface. So that is why you cannot even make it default. That's why they have made it public by default. See, if you try and change it here, if it is public here, it has to be public in the child, right? If I make it protected here, then it is problem. I am trying to reduce the access level. It says cannot reduce the visibility of the inherited method flyer because the previous one was public. So by default itself, the methods are declared as public and abstract in an interface. So I hope these rules are clear. All interface methods are public by default and they are even abstract by default. Public and abstract by default only. Interface methods don't have body. Interface is set of abstract method. So I'll first put this example, and interface is what for they are used. Non-related classes can share common behavior and common behavior. In such case, create interfaces. Okay. So whenever non-related classes are sharing the common behavior, at that time we are going to create the interfaces. So let me put this assignment first. Let me put this example first into the repository. So this is our session 18, I guess. Yes. So day 18. This is demo 1. Interface. So I created an interface. Then the implementing class, all the classes are not at all related to that interface. That means they are utilizing the interface, but they are not related to it. One simple example I'll give you how two objects can be relevant or can be utilized by non-related objects. For example, if you are traveling in a Ola, right, and some XYZ person travels in an Ola after you. So are you related to that person? No, you are not related. But still both of you are sharing that common Ola, right? So interfaces are like that. Classes can use common behavior without being related to each other. I hope that example has cleared you the concept of interfaces. As for now, what you can just consider as classes utilize the interfaces. Just consider that. And there is one very important point with the interfaces is that interfaces are set of rules, set of protocols. Interfaces are set of rules. Now what rules? We will understand that rule later. So now what I will do is I have already implemented this, but one question that comes up into our mind is that and now when we are creating these classes, it is easy for us to create a service class and then create instances of this and call the fly method and all, so which we have done in the previous session also. So let us create a service for this. We can have a flyer service. and create a main method and create instances of each of the class, and then we can call it. So it is easy for us to directly create the instance of a class, or even interface instances can be created by referring to the child classes like bird. Dynamic method dispatching, if you remember. Now if I create an instance of this flyer, at that time I can only call the methods from the flyer, which is fly. If there is a bird specific method, I cannot call it. So now it will show me bird flies. So this way we can create it, right? So same instance of flyer can give me different result based on which class is referred with it. So if I refer it with aircraft, it will tell me aircraft flies. If I refer it with Superman, it tells me Superman flies, right? Flyer 3. So all three, it will give me the result. But as we know that if a bird has, or an aircraft or a Superman has some specific method, like maybe public void Superman, maybe Superman flies and also saves life. So this method cannot be called by the flyer object. Saves life. Okay, so if I go here and then try to call flyer 3 dot saves life, I cannot call it, right? If I try to do that, there's a problem because it does not understand that saves life is a part of flyer. We are not referring to this method. Specific child specific methods cannot be called when we are trying to create the instances for dynamic method dispatching. We already know that from the previous session itself. So calling this will be invalid. Rest all things can be easily called. Okay, so I'll give you this flyer as well. So let's add a demo to this. Flyer service. Now, whenever I explain interfaces, I ask people about a very simple question, which sounds more logical also. See, whenever we are using interfaces, point number one is that interfaces are set of abstract method, right? So fly method has to be written here, and then fly method body is given by this class, by this class, and by this class. So since the method body is given by the implementing class only, why do we need to implement the interface and mention the method in an interface, right? We can easily create a flyer that does not implement the flyer interface. That is, let's say for example, I have a class, and then what I do is I create another flyer, maybe a parrot or a pigeon or a peacock or a hen or a eagle, whatever, like anything that flies. So I create a class eagle, and I do not implement an interface, and I just say that eagle flies. So I'll just copy this method from here. I'm not overriding it. I'll just copy it because there's no parent, or there is no implementation of any interface. So I'm just saying that eagle flies. All that is fine. So in a flyer we can directly go for what? We can go for eagle. So this will be valid one. Eagle e equals to new eagle, and then e dot fly. So this is possible, right? So whichever flyer we have, we can directly go ahead and implement the flyer method, because anyhow the body is given into the class only. The body is not given in an interface. If it was an abstract class, then it is logical because other methods can have body. Whereas in an interface, none of the method has a body. So all the methods has to be defined by the classes only. So why to create an interface at first? Why not directly create those methods inside a class itself, right? Getting the question? The question is, if I have to implement the method inside the class only, why am I creating an interface at first and implementing that interface? So the bird class could have been written like an eagle class, right? Without having an interface and without implementing it, which saves your time. Creating an interface will take time, and also implementing the interface will take time. So why is that required? The question is clear. So let me give you the answer for that question. If the question is clear, let me first put this into the repository. So demo 3 problem, what is that? An eagle can be created without having an interface, and the fly method of an eagle can easily be called. So why should we create an interface? So here I will add that question, why to create interface and implement it if the class only has to define it. The method has to be defined by the class itself, right? So when the class is defining it, why to create and implement the interface? Has to define the method, correct? If it is the responsibility of the class to create this method and define the body for that, why we are creating this method in an interface and why doing all that drama, right? So let me comment that and give you the answer for that. See, I have two classes now. One is eagle, another one is bird. So we know that both bird as well as eagle flies, and both of them, they have implemented the fly method. Eagle is implementing a fly method without implementing interface, flyer interface, whereas bird is implementing the flyer interface and it is also defining the method fly. Now see the difference. In an eagle class, I can add more methods. Bird also I can add more methods like public, void. Let's just add a ABC or something, or maybe eagle eats and bird eats and all that. So an eats method. So I added an eat, or maybe some other method, hunt and all that. Okay. Similarly, these two methods can also be added into a bird, right? These two methods can also be added into a bird. Now, while creating this eagle class, I may forget to add a fly method. Possible, right? So if you see that there is no error on this eagle class, I may forget to add it. But when I am creating a bird and I forget to add this fly method, the bird class will never be created. See, the bird class started giving me an error. It says me that you are saying that the bird is a flyer, then it has to fly. So if you mark any class as a flyer, then it has to fly. That is the rule that a interface brings in. So if you see it here, interfaces are set of rules. This is the rule that an interface ensures. So what interface is doing is that interface is ensuring if you are marking it as a flyer, then it has to fly. So that means you need to implement that method fly here. But when you are saying an eagle, eagle may fly or may not fly. There's no such rule for it. If it implements, it is well and good. If it does not implement, that is also fine. Correct? If it implements the fly method, it's well and good. But if it does not implement, then at that time there is a problem. So to maintain that standard, to maintain those rules, we have to implement interfaces, so that interfaces ensure this particular method is overridden by the class. Hope the answer is clear to you. Okay. So let me put this solution into the repository as demo 4 solution. This is eagle class without a fly method. Eagle class can be created without a fly method, as there is no such rule to create a class with fly method, right? If I do the same thing with bird, if I don't create this, then error creating bird class, because bird implements flyer, it has to define the fly method, which is a rule, right? So this is what the difference between implementing the interface and not implementing the interface. So whenever you are implementing interface, you are ensuring certain things are overridden for sure. Certain rules are followed for sure. So hope the concept of the interfaces, where do we apply the interfaces, is clear. And also why to apply interfaces, why not just directly create the classes, is also clear to you. And why to create interface, why not just the abstract class, right? If you're creating abstract classes can have the methods with the body as well, and abstract classes creates kind of relationship. That means anybody who is uh, implementing this behavior has to be a child, whereas for interface it may not. Any non-related class can use it. Another advantage of using an interface is that, see, suppose if I create one more interface, let's call it as inter1 or interface demo, and then I have a demo method created here, void demo, some method. All the methods has to be abstract, so I'm just marking it as abstract method. So it is an interface. Let's save it. So the advantage of this, yeah, now eagle does not have this fly method, so that's why that flyer is giving me an error. So I don't want an eagle. I'm done with that eagle class. So this also will give you an error. A specific method cannot be called. So let's clean up that. Now what I have done is I have created another interface called as inter demo, and bird you can see that can implement the flyer, plus it can also implement the inter demo. And the moment it implements the inter demo, it has to override the methods present in both the classes, right? So add the unimplemented method demo system.out.println method from inter demo. Let's save it. And then what we can do is we can go to this flyer service, and this bird is actually being created from flyer. So we will directly create the bird is equal to new bird, because see, if I create it with the flyer, obviously flyer does not have the method, right? It does not have a demo method. So who has the demo method? It is the part of the inter demo. So I have to either create an inter demo or directly create the bird and call both the methods. So call the demo method, call the bird dot what was the method, fly method. So both can be called, and even bird specific methods can also be called. Bird dot, I think I've created a eats method there. So all those methods can be called. So multiple methods I'm calling. You can see for bird, aircraft, Superman, and then method from inter demo is also called bird flies. From both the interfaces it is called. So which means that a class can implement more than one interface. Okay, classes can implement more than one interface, but still it is not inheritance. Whenever you use the keyword implements, it means that you are utilizing the interface. It's not inheritance, because Java does not support inheritance with classes. So let me give you this example as well, where multiple interfaces can be implemented by a class. Demofy class implements multiple interfaces. So it is possible for the class to implement multiple interfaces. So you can see that here in this example, I'm implementing the flyer interface as well as the inter demo. So this is my flyer, which contains one method, that is fly, and there is another interface that I have created, inter demo, which contains a method called as demo. So I'll add that here, and also for your convenience, I'll add a service class with just what is required for this example. So flyer service, copy this, and let's remove the non-relevant stuff from here, which is not required. Only the bird class I am implementing. Done. So it is possible for a class to implement more than one interface, and there are some rules that you have to remember. That is, class implements an interface. Let's write it here. Class implements interface. Class extends class. Okay, and that's it. You cannot like write an interface implementing class or interface extending a class. That's not possible. Interface extends class, not possible. And then interface implements interface, not possible. So this is not possible. What is possible is class implementing an interface and class extends a class. Only this is possible. Class can implement more than one interface. Class can implement more than one interface. And interface. See, a driver cannot be a child or parent of a car, right? A driver cannot be a parent or child of a car. That's why class and interfaces, they are two different objects. They cannot be parent and child. But class and class can be parent and child. Class and class can be parent and child. Similarly, interface and interface can be parent and child. Means interface can extend another interface. So it is possible for an interface to extend another interface. So what I will do is, here in this example that I have created flyer service, so I'll take all these points from here and I'll create another class, and then class interface test is something I'm adding, and there I will add this. Okay, all of that is added. So this interface test is what I have created, class interface test. So we have seen class implementing an interface, class extending a class. We have seen that. Class can implement more than one interface, which we have already seen just now. Now interface and interface can be parent and child, means interface can extend another interface, that we have to see. Also, yeah, first we will see that interface extending an interface. So here I will create one interface flyer child. Okay, extends flyer. Okay, so I have created a child of this flyer interface called as flyer child, and then I create another, since it is an interface, it can extend interface. So I'll create one more method here, that will be child method fly or something. I'll create, let's call it as void child method fly. Now since flyer child is a child of flyer, it means that it has two methods in it, right? So if my class interface test implements flyer, then we know the rule. We have to add the unimplemented method fly, right? And if my class implements a flyer child, at that time I have to actually override two methods. You see it here. If I try to override only one method, problem. So I'm giving the body for this method, and when giving the body for this method, I have to ensure the rules of overriding are followed. We cannot reduce the visibility of the method. So this is fine, but still we are getting an error. See, it says what? The type interface test must implement the inherited abstract method from flyer.fly. So I have to write the child method as well as the parent method. I have to take fly as well as the child method fly. This will be valid. Okay, so what is the rule? Rule says, if you are implementing child interface, you must override all the methods from child interface and parent interface, since child inherits all the parent behavior. Okay, so since child is implementing all the behavior of the parent, you must implement what? All the methods inherit all the override all the methods that belong to the parent interface as well as the child interface. So let me put this child interface. So if you are implementing child interface, so in this case we were implementing the child interface, which is flyer child. If you are implementing the child interface, you must override all the methods from child interface and parent interface, since child inherits all the parents method. So here we go. This flyer is inheriting the fly method. So basically it has two methods. One is this fly method inherited from parent. So it has two. One is this fly method, and another one is this child method fly. So that's why this class has to override both the methods, the fly as well as the child method fly. So I will give you this example first. Demo 6. Inheritance in interface. So interface inheriting another interface. This is inheritance with interfaces. So inheritance with classes is different, inheritance with interfaces is different. And also if you remember in my previous class I told you that abstract method can only be written into an abstract class. And also I told you there are certain things in which an abstract method can be written. So that is an interface only. It is possible for an interface to write an abstract method. Instead, interface is a set of abstract method. So in this example, what I have is I have a flyer parent method, parent interface, and then a flyer child, a child interface, and the class implementing the child interface. Because the class is implementing the child interface, it has to override both the methods from the parent and from the child. And one very interesting point about Java does not support multiple inheritance, right? So I have written Java does not support multiple inheritance with classes, but Java supports multiple inheritance. Now what do I mean by Java supporting multiple inheritance? You see it here, interface child 2, or maybe, yeah, there was one inter demo that I have already created, right? So let's create a demo interface or demo inter and add a method demo in it. So now you see I can implement this flyer child, right? So which is not inheritance, whereas this is inheritance. Flyer child extends flyer is inheritance, right? Extends. So interface can be a child of another interface. Now if I do a extends here, extends fly comma inter demo. Sorry, it is flyer, not fly. So flyer as well as the inter demo. Now inter demo already has a method called as demo. Let's create it as test or something, maybe something else. So what happens here is, what is happening here is interface is extending from more than one interface. That means multiple inheritance is available in Java. So multiple inheritance is possible with interfaces. So let's add that point again. So I'll clean up all these points that I have written before. One important point that I am focusing is multiple inheritance is possible with interfaces, meaning an interface can extend more than one interface. So some people are again confused about the multiple inheritance is possible with interface. What they think is that if a class is implementing more than one interface, they consider it as multiple inheritance. But it is not multiple inheritance. That is just a feature like multiple inheritance. Whereas this is actually multiple inheritance. A child interface extending from more than one interface. So because this is the multiple inheritance here, the demo inter is a child of flyer as well as inter demo. So here it will actually have three methods. One is the demo method coming from this inter demo, right? Demo method, demo from inter demo. Another method that it has is fly method. from flyer. So if suppose now if I implement, instead of this flyer child, if I implement demo inter, at that time I have to, this is not an overridden method, fly has to be overridden, then I have to override this demo method. So demo method has to be overridden, and also something else needs to be overridden, something else. So something else from the child interface, okay, which is demo inter, inter demo, from inter demo this demo method, and from flyer this fly method. So all these three has to be implemented, because whenever we implement a child interface, we have to implement all the parent interface methods as well, right? So let me give you this example as well. Multiple inheritance now with interfaces, that is also possible. Demo 7, multiple inheritance with interfaces. So I'll add this main class, and also you, for this you would need the flyer interface, and in this case this interface flyer is not required here, flyer child is not required, so I'll remove that. So you need a flyer for this because that is one parent for it, and I'll remove this comments from here, not required as for now. Then the inter demo interface is required for us, done. And lastly the interface demo inter extends flyer and inter demo. Then the class implementing the demo inter, which means it has to call the demo, fly, and something else, so which is all overridden here. I'll also add a override on top of fly so that you understand that that method is also a overridden method. So it will be a very tricky question if somebody asks you, does Java support multiple inheritance? If you say yes, the answer is wrong. If you say no, the answer is wrong. Why is that? That is because Java supports multiple inheritance as well as Java does not support multiple inheritance. How do you explain this? So it is easy to explain. What you have to do is you have to be very much clear. It is not a yes or no answer. If somebody asks you, does Java support multiple inheritance? It's not a yes or no answer. You have to elaborate it. What you can say is, Java does not support multiple inheritance with classes, meaning a class cannot extend more than one class. Whereas Java supports multiple inheritance with interfaces, meaning an interface can extend more than one interface. So this would be a more logical explanation to the question about Java supporting multiple inheritance or not. So what you do is you practice these interface concepts, and in my next session I will be highlighting you about the marker interface, which is again a very important concept in Java which people does not talk about. So we will talk about marker interfaces, how marker interfaces comes into picture, and the marker interface is one that does not have any method. So how come interface without any method be useful for us? So in our next session is going to be very much interesting. So stay tuned for the next session where we will talk about marker interfaces. And I hope the rules about the interfaces and where to apply interfaces is clear to you in this session. If you like the series, stay tuned with the series, and do share the series with your friends. And if there is any doubt, you can ask on the ask in the comment section. So see you in the next session.